In our last lesson, we learned about the absolute value of a number and how to find absolute value solutions for equations. So we're going to review that a little bit. So absolute value represents distance. So what we learned here last time was that if you have an absolute value that is equal to a number, then you will have two solutions. And here we had x is equal to -2 and x is equal to +2. Now the difference in what we're going to talk about today are distances that are a range of numbers. So what this is telling me is that the distance from 0 is less than 2. So let's look at a number line. And I'm going to put my 0 on here, and 2, and -2. So for a distance to be less than, that means we can't travel any further than 2 and any further than -2. So all of the values of x in here are going to be between those two numbers. So we can write this as an inequality like this, because the x is between -2 and 2. So what we're going to do is we're going to end up making an inequality sandwich. We're going to take what's the inside and make a sandwich with it between -2 and 2. Now at the very top of our page you see the word and the way we read this is that our x is between -2 and +2. It includes all of these values. It doesn't go past any of the other two values. So the same rule applies as before about the rules for solving and graphing. You still must solve for the absolute value. And a good way to think about it is get the absolute value alone. When the absolute value is alone, then you can separate it. Now we have another lesson where we're going to talk about what happens when you go beyond these boundaries out that direction, but that's not for today. We're just going to stick with looking at what happens between right here. So this is an and problem, and in our lesson about inequalities we talked about those before. Alright, so we're going to make a sandwich. We never change what's inside. Never change what's inside. So we're going to take 3 minus x, and we're going to sandwich it between the +2 and the -2. Order matters, always, always, always. So we want to get the negative x by itself. So we're going to subtract 3 everywhere. So -3 here makes a -5. And then this gives me a -1. So I have negatives. I don't want a negative x, I want a positive x. So we can think of this as we're going to multiply everything through by -1. And what happens is not only are you changing these signs, the signs of the numbers, you're changing the inequalities as well. So that gives us 5 greater than x greater than 1. Now I'm going to flip that over simply because I like to write it in order from left to right. So when you flip it over, flip these signs as well. And it looks like we're kind of going backwards, but we're really not. So what this tells me is that all values between 1 and 5, but not including 1 and 5, will satisfy the inequality that we have above. So why don't we test it out? This is an optional thing, but let's test it because it's a good idea to prove it to ourselves. So I want to pick a number between 1 and 5, but not including that. So I want to pick x equals 2. Let's plug it in. 3 minus 2, absolute value less than 2. Is that true? That gives us absolute value of 1, and that is true. So I proved it to myself. This is one way to show your answer. The second way to show your answer is graphically. So on my number line, I'm going to put the 1 and a 5. And because we don't have equality, we're going to graph this with an open circle and then connect everything in between. And that's a graphical representation. Now, if you're my student, you have also learned interval notation, and that is the third way to represent our answer. So our interval begins with 1. It does not have equality, so we're going to use a parentheses and comma up to 5, close with a parentheses. All right, let's try another one. All right, let's set this problem up. I see I do have some equality here, so that makes a difference when we graph and when we write an interval notation. So I'm going to begin with sandwiching 3x plus 2 between the positive and the negative of 4. All right, so let's solve for x. You want to get that x alone. If this is an equation, you would want to subtract 2 and then divide by 3. Either direction if it was just an equation. Same thing, except we're doing it in 3 places rather than 2 places. So we're going to subtract 2 everywhere. And then we're going to divide by 3. If you were my student, you know my rule about repeating decimals is just don't do it, just say no. So we've got our first representation of our answer. The second representation of our answer is going to be through a graph. So we're going to read this. All of the x values between negative 2 and positive 2/3 will be our solution. So we're going to put this on our number line. Order matters with numbers. And because it includes our values of 2, we're going to use a closed circle. And we're going to do a closed circle on 2/3 as well. And we're going to connect them. We have a sandwich of values. Now, the last thing we're going to do is write this in interval notation. Now, if you remember, our greater thans and less thans without equality are parentheses. If you have a less than or equal to and a greater than or equal to, you're going to use brackets. And it's easy to remember because equal signs are straight and brackets are straight. So we have a closed circle, which means a bracket, with negative 2, comma, 2/3 with another bracket. Now for example 3, we have subtracted 1 from an absolute value. And just like equations, we cannot solve this until we have gotten that absolute value all by itself. And so to do that, we're going to begin with adding 1 to both sides. And remember, no changing the inside until it's alone and the absolute value symbols have been dropped. Okay, so we have 5 minus 2x, absolute value, less than 3. All right, so if you remember, we're going to sandwich 5 minus 2x between negative 3 and positive 3. And we need to get the negative 2x alone, so we will subtract 5 everywhere. Just like that. And then we're going to divide by -2. And remember, dividing by negatives changes signs of numbers and direction of inequalities. So that gives us 4 greater than x greater than 1. Now we want this in order. This is out of order. The 1 needs to come first, which means we're going to switch everything. So let's flip it over. So we have 1, and if you see here the little end is pointed at the 1, we want to keep it that way. So this says x is between 1 and 4. So we graph it. 1, 4, open circle. Why? Because it does not include 1 and 4. It means there's going to bump right up next to it. And then the last thing is interval notation, open circles or parentheses. And there we have it. All right, we're going to finish this up with some fractions. And fractions are not scary. They just look a little more complicated than normal numbers, but we're not going to be worried about that at all. Same rule. Okay, first of all, the x plus 1 is divided by 2, but it is inside the absolute value. So we're going to leave it there for right now. So the first thing we'll do, inequality sandwich between the positive and negative of what's on the outside. Now what I notice here is that we have a denominator of 2 everywhere. So we are going to multiply everything by 2, which means all of the denominators cancel. And what we are left with is -3 less than or equal to x plus 1 less than or equal to 3. And suddenly our problem does not look so complicated anymore. It's really very simple. So we're going to start by subtracting our 1. And there we go, we're done. So I'm going to pause the video, you graph it, and put it in interval notation, and then come back and check your answer. And there we go. We are done. We have solid dots for our graph, and we have brackets for our interval.